Thank you all for coming. I'd like to introduce Professor Brian Wilson. Brian is an assistant professor teaching stream in the Department of Physics at the University of Toronto. He received his PhD from the University of Toronto in 2009 and began teaching as a sessional lecturer in 2010. He first taught at the University of Toronto Scarborough campus before moving to the St. George campus, where he has taught full-time since 2022. For the past 8 years, Brian has been interested in questions of pedagogy, such as how to improve our lab courses and how to create more meaningful formative assessments in our large undergraduate physics courses. So thank you again for agreeing to do the colloquium on relatively short notice, and we look forward to it.
Okay. Okay, thank you for that introduction, and thank you for all showing up to come and listen to me talk about one of my pet projects at the moment, which is generally in teaching, but it's specifically in making better formative assessments. The talk title is about MathMatize and formative assessments. Those are the two key words I think that maybe not everybody knows much about. MathMatize is just a brand name, but I'm going to talk a little bit about MathMatize, talk about formative assessments and what I feel like good formative assessments should be. And then we'll go on and spend most of the time talking about MathMatize. If you want, there's a URL here that you can log on early. I will have an example program, but if you've got a smartphone, I would actually wait till later. There's like a QR code, and that'll be a lot easier to log in that way. Okay, so basically, no, why is this not working? Okay, let's try just clicking. There we go. Is that working now? There we go. Okay, so mostly MathMatize it's a standard, well, it's a new-ish educational technology tool. It's roughly equivalent to, say, Learning Catalytics or Top Hat or those sorts of software that you might have used. It's good for both doing polling questions. So in the middle of a class, you just stop and you put a poll out, and everybody pulls out their devices and they start working on it. You can also use it to make assessments, like you could do timed quizzes and that sort of thing. It's got all sorts of tools for that. But mostly what I'm using, or we'll be talking about, will be for these post-class quizzes. So I've got these quizzes that are basically homework assignments. They show up the day after the class, and they've got like a day just to do them. And that's what I've been using them most for, and it's spending all my energy in improving. Okay, and just a quick disclaimer, while I have drunk the Kool-Aid in this thing, and I really, really like this thing, I'm not actually making any money. So while I am hoping to advertise this and push people to use it, it's just because I think it's really cool, and I think you should think it's really cool, and I think you should be using it in whatever courses you're teaching in the future. Okay, it was developed by Jonathan Herman, who's a teaching stream faculty out at UTM in the math department. So it is relatively small but growing. It is relatively local. I've asked him about his plans, and he likes it, and he likes working on it. He has no plans yet to like sell out. On the other hand, it is true that if if a publisher offered him a whole bunch of money, he might say yes. In which case, if you put a lot of effort into building your course around this, that effort could disappear. It could get locked behind a textbook. But right now, it's not locked behind a textbook. It's just an app that's completely separate. Okay. So in terms of assessments, in pedagogy, there's it's not a binary, it's a spectrum, but basically there's the two opposite ends of what we talk about for assessments what we talk about are formative and summative. And the easiest way to sort of think about what they are is homework is the formative stuff. Stuff that isn't stressful tends to be the formative stuff. Whereas the summative assessments, those are like your final exams. They're basically the instructor saying, okay, now that the course is over, I need to rank everybody because that's what the university says I have to do. And I mean, I don't love that part of my job, but that's part of my job. But that's what the summative assessments are. They really are for like ranking students and saying, by the end of this course, how did you do? And of course, not everything needs to be on the ends. Quizzes tend to be somewhere in the middle. They're a little bit of a ranking exercise because they contribute a little bit to your grades in a challenging way. Whereas like homework, when I'm doing homework, when I'm making my homework assignments, I basically just assume everyone's getting basically 100 on the homework, right? Because if you've got a week to do this, you should be able to figure it out by then. Okay, so Another way of looking at what formative assessments should be is they should be the student's chance to get a check to see if they figured out what's happening in class. Right? So if you're going along in the middle of class and you stop and you give them one of these in-class polls, that's a chance for them to say, okay, I just heard 10 minutes of this stuff. Now I have to calculate it. Do I actually know what's going on here? Or is this just, in one ear and out the other ear? So well-designed formative assessments should be geared around helping the students figure out yes or no, did they just figure that thing out? Personally, when I first started teaching, 15 years ago, I thought the formative assessments were easy. I just make homework assignments, give it to them, tell them that some of those questions will show up on the exam, and obviously the students will do a good job of working on the homework. I found the summative assessments much more difficult. David Harrison helped me a lot to figure out how to write good tests, especially the multiple choice questions. So I spent most of my first 10 years or so just worrying about this. And now that I don't have the exams perfect here. One of my tests just recently, I think, was a 50% average probably. The marking's not done. I thought it was going to be a 65. I clearly did something wrong. So I'm certainly not perfect here. But I think my understanding of formative assessments was a little naive. And now that I'm looking at it more, I realize, okay, actually just giving people homework isn't really enough. Okay, so just to talk a little bit about what I now think good formative assessment should look like. First of all, and this is sort of obvious, I guess, the challenge has to be appropriate. If you're doing an in-class question as a formative assessment, they have had 10 minutes to think about it. They've got 10 more minutes to do it. You can't make this a super hard exam question. It has to be something relatively straightforward. But when you do get to your homework, that should be more challenging. My personal philosophy is my homework questions should be about the same difficulty as my exam questions. And if I do that, then the students have a sense before they show up to the exam whether they're prepared for this exam. Okay, so appropriate challenge, but I assume everybody's on board with that. Next thing, which I've only recently come to think is actually important, is they have to have some utility, and that utility has to be clear to the students. If you just give them homework, my sense is the standard incoming belief of most of our students is that we're all incompetent at setting exams. Our exam averages are too low. And so we give them homework to pad the class average up so that the final average is where it's supposed to be. And so if they have this mindset, then when you give them homework, they say, well, I'm not learning from this homework. I'm just doing this work. I'm jumping through these hoops so that I can get the credit so the class average comes out okay. And as long as that's true or even sort of true in their minds, their temptation to not work hard on this homework is pretty high. So by way of context, I'm teaching the first year engineering science students. I've been involved in that course for 7 years now. When we gave them homework that we marked, class size of 300 students, average assignment had 5 answers. Okay, they were working in groups. They were very efficiently dividing and conquering. Few people did any of the actual homework questions. And my sense was partly they were just overworked and they just ran out of time and they had to do something like this, but partly they just didn't see the utility of actually honestly doing the homework in that course, right? So if you can make these assessments, and not just the homework, the quizzes and everything, if you can make them relevant to the students and communicate to the students that they are relevant, then they tend to engage. At least this is my impression, my personal experience. And then finally, if you want a formative assessment that's truly formative, which is to say it's truly something that helps the students figure out for each topic, did I get this or do I have to review more? They need feedback, right? And so you need to give them some sort of feedback. It needs to be effective. And one of the things that the last few papers I've read on these sorts of things have been saying is that speed is important. If they hand in a homework assignment and a week later you tell them what happened, that's just too slow. It took too long. They've forgotten about all of that. They're probably working on their next assignment. This is just not useful feedback to them. And at some level, good luck getting them to read any of the feedback you did, right? Even if you paid your TAs to say, okay, make sure you clearly show where they went wrong and all that, chances are most of them don't spend a lot of time looking at that feedback. So if you want your feedback to be effective, timeliness is important. And honestly, for all of our big courses, you got 300 students, you got 1,000 students, whatever, your TAs just can't get through that in under a week. And so it's kind of hopeless. And so I think it's important that we have some formative assessments that are graded automatically. And that's one of the things MathMatize does. MathMatize can just, you tell it what the answers are, and it says, okay, this person was right, this person was wrong, and they get that instantaneous feedback. For the record, I'm not saying we should get rid of homework. Homework is still a very, very useful thing, especially when it comes to exams. On exams, you need to write out the answer to this question in a nice, logical, coherent way so that the marker can understand that you understand what you were doing. And homework is how they practice that. These quizzes, everything I'm going to show you about MathMatize doesn't train that skill at all. So I'm not saying replace your homework with MathMatize questions. I'm just saying add some of these MathMatize questions. Add them in the form of in-class questions or post-class quizzes or something like that. This is my belief that MathMatize is a really useful tool, but it is an additional tool. And then, of course, a final note about this is if you just add MathMatize to your current homework workload, you're probably going to overburden your students. They're going to run out of time. And I promise you, as soon as the students are running out of time, they get very efficient at how they get all those marks again, right? So if you want to add some things from MathMatize, I suggest you pare down your homework a little bit so that the total workload of the students is sort of even out and you don't overwhelm them. Okay, cool. Okay, so that was the sort of the theory, the pedagogy sort of theory side. So now I'm going to talk about MathMatize and specifically, why I chose to use it, how I use it, and we'll have some sample at the end. And just generally, like if you have any questions, don't feel like you have to wait till the end of the lecture to talk about them. Like just ask the questions right away. Okay, so why do I like MathMatize? And when I say it's actually we. Anya is the one who introduced me to this. It's starting to filter out through other courses. I think so. I'm using it in Physics 180, 151, I think, and 152 are using it. I don't know the other big first year courses are, but there might be doing it soon. So it's not just me, and all of us like it for these reasons. But first, the two important ones at the top here are the price tag and this thing called math equivalence. So the price tag is nice. Their pricing model is that they charge the department, which Peter has been very kindly saying yes to. And if nobody's asked you yet, Peter, please bring it in again next year because it's amazing. But the department goes, it's paid by the department, so it's free to the students. And my understanding, I don't know the actual price tag, but it seems to be like an order of magnitude cheaper than like Top Hat and its competitors. So it's relatively affordable, and it's especially affordable to students, which I personally think is important because I don't love teaching courses where students with more financial resources can be more relaxed and do well, and students on a tighter budget have to make some decisions about this. Okay, and then math equivalence. This is one of the key issues that separates it from its peers. If you say the answer is log A over B, and somebody types in log A minus log B, it says, yeah, those are the same answers, and it marks them both correctly. Right? And this is not something that Quirkus does. This is not something that most of the competitors do. It's not AI. It's not quite as good as even Wolfram Alpha, but it's like close to being as good as Wolfram Alpha at figuring out that this equation, this equation, this equation, that they're all the same thing. Okay, and that means you can give your students questions where the answers are equations, and then they can just answer with equations. And this is what makes it, to me, something that I can use in my second year electricity and magnetism course, right? Most of the other ones, it can accept numbers, maybe numbers with units. And I'm not asking my students in second year those sorts of questions. But if I can give you an integral and say, what's this integral symbolically? Well, at least you have to do the integral, but you can just put in the formula for the answer. Like it says, yeah, you got it right. And as long as it's one of the correct versions, it reduces it to the same base and says, okay, yeah, you got the answer right. So that's most of why I really like it. Also why Anya really likes it and told me that I should start using it. Other things, it's relatively simple to use, especially it's like native LaTeX. So you just in the window, you just type in your LaTeX. There's a couple of new symbols you have to learn to say put a blank here and put some variables here. But other than that, it's basically just basic LaTeX. Its dependability is pretty high. Even in a class of like 300 students, if you're running it, it doesn't slow down hardly at all. It's just very reliable. It runs, it's purely a browser app. So there's no app you have to download onto your machine. And the resources are relatively minor. And like literally a smartphone is good enough. Honestly, I don't love using the smartphone because I like typing in on my keyboard and I'd rather type in the answers than use their keyboard. But I mean, it's certainly usable. Okay. Okay, and then another reason why we like to use it is largely that the students really like to use it. So this data is a bit more than a year old now. So these are the these are the second year courses we were doing. So Anya was teaching, I think, 293 at the time, and I was doing the electricity and magnetism. And these are a bunch of first year courses, so it includes my physics 180, and I think Anya was teaching 132 and 152 at the same time. And the students just really like it. Basically, these are the brown and the reds are really like it, or sorry, it's a great deal. They liked it a great deal, or they mostly liked it. Well, you can't really see the endorsements, but basically how many students liked it is roughly tracks just the brown and the red. So the students really like it. The students in an online section especially like it. You're adding some engagement to an online course. So if you've got any online sections, any online tool like this is just a really useful tool for student engagement. Okay. So now the how part of this, which I know is misleading because I talk about why, but how I use it is I'm using it both for in-class polling questions and then post-class assessments. So the idea is I give them a bunch of, actually, I usually give them one question after every class. It shows up the day after the class, so they have to sleep on it. And then they got like until the next class to solve it. And why would I do that? Why don't I just have your traditional homework? And the why of it comes from Ebbinghaus's forgetting curves. So this is research that's like 140 years old at this point. So 140 years ago, Ebbinghaus just looked at how do people remember? Well, actually, how do people forget? So these are curves of basically how much memory retention they have. And the idea is if you're exposed to some new idea and you never think about it again, your ability to recall it just sort of drops exponentially and it tails off, not quite at zero, but in the long run, you don't learn much. And the way to defeat this is to keep reviewing it. And so they went through and they made people review it at certain time intervals. They changed up the different time intervals. And again, 140 years ago, they decided that this was basically the most efficient method of learning, assuming that you're not just learning this one material, that you've got lots of other things you want to learn too. And this time scale is, I think this time scale is roughly on the scale of like a week. So these are like 1 day, maybe another day and a half, a week sort of thing. So you don't want to let people go very long without reviewing, because otherwise they come down here and it's basically like they're just learning it again from scratch. Okay, so normally, when I was a student at least, I would come to class, I'd have a tutorial, I'd have a homework, and that would be it. And the homework was often like every other week, so it might have been 2 weeks away. And so I would have forgotten a lot by that point. And at least according to this, that was not the optimal thing. We want 4 assessments, and that's where adding like one of these quizzes going in. Now, you might ask, well, that was 140-year-old research. Some people reproduced it about 10 years ago, got effectively the same results. In fact, even the timing seems to be right, that this was in fact the right spacing. And so you really just seem to want to make people look at something, look at it again about a day later, look at it again a couple of days later, look at it again a week later. And that's sort of the most efficient way to make sure people to learn it. So we kind of want 4 assessments, and the default is, like I said, class, tutorial, homework, and that's really only 3. So we need to add one. I could have added a pre-class quiz, but my experience with pre-class quizzes have been very, very hit and miss, and mostly miss, to be honest. I can't seem to make a pre-class quiz that the students take seriously. Mostly they seem to look at the quiz, open up the PDF of the textbook, search for a couple of keywords, cut and paste the answer, get the right answer, and they're done, right? And that's not really the engagement I was looking for. And it's not just me. Again, I've seen some research that suggests that pre-class quizzes are actually really, really hard to do well. If you really want students to learn from pre-class quizzes, you have to spend a lot of effort to do a good job of it. That same research, however, suggests that post-class quizzes are super easy to do. As long as you make them look at almost anything related to the thing you just taught them, that's going to help with this memory retention. And so the post-class quizzes are just easier to do well. So my first few blushes, maybe someday I'll go back and try to figure out how to do the pre-class quizzes properly. But for now, the post-class quizzes are working for me. And again, my post-class quizzes are a day later. Yeah, so the next day it opens up. They typically have till the next class. I'm actually thinking next year I should actually make it so that it's one day no matter what. Because if I have a class on Monday and Wednesday, if the Wednesday class, they don't actually review it until Sunday night, and I can see the statistics, 80% of my students are waiting until Sunday night as late as they can to do this thing that's due on Monday morning. So that's on me. I should have known that. I would have done the same thing, to be honest. So I expect next time around, I'm going to move that deadline earlier. So yeah, so this is what I'm doing. And my typical question is, one of the questions that we worked on in class, I just do a philosophically similar one. So like if we did the magnetic field of a straight wire using Ampere's law, now I'll do a sheet. Let's do Ampere's law for a magnetic field around a sheet of current instead. So it's a very, very closely related. And if you knew what you were doing here, this should be like a 10 or 15-minute thing. So I really am consciously keeping it to one question, very closely related. I'm hoping to keep it down to the, say, 10 to 15 minute of workload. Because I really do feel once the workload gets above 8 or 9 hours a week, they're just going to stop putting effort into it. And they're just going to say, right, these are just hoops to jump through to get the marks because the test average is going to be low. I also, to make it more formative, I give them multiple attempts. So I think for the electricity and magnetism course, I'm giving them 3 attempts. Each attempt, it tells them what their grade was, but it doesn't tell them which ones they got right and which ones they got wrong. But when I look at the averages per student are something on the order of like 90, 95%. So with 3 attempts, and I explicitly encourage them to talk to each other. They are allowed to come to me during office hours. In my particular course, my office hours are on Mondays, Wednesdays, the same as my classes. And so it's not actually available on Tuesdays, so people aren't. But they're allowed to just track me down and ask. They can talk to each other. All of this is because I want this to be purely formative. I don't care about ranking my students based on this. I also, while it is marked for correctness, I have a cushion. I say, okay, there's this many credits in the formative assessment pool, and you need to get 2/3 of them to get all the marks. And so the students are not stressed about losing individual marks here and there. 2/3, 3/4 of my class get perfect on these formative assessments at the end of the year. And so I think, and this is all speculative on my part, I haven't actually got any data for it, but I think for the most part, the students are engaging with these activities authentically. They're trying to actually use them to figure out if they're learning. They're not skipping to AI to get the answer as fast as they can. Okay, so now some examples. Ooh, I talked faster than I thought. Okay, well, so here's one of more straightforward sort of examples. So this is just a question you're asking. You can see that you're just typing in LaTeX. It's got a preview over here where it shows you all your equations are looking nice. And then the only thing you have to learn is that a double square bracket means we're going to create a variable. And by default, those variables are something you're going to give a spread of random values. So you say, I want the length to be somewhere between 5 and 15 with whatever units it is. Looks like centimeters. So 5 to 15 centimeters with 1 decimal place. And so every student will get a different number. And then you just, for each one of these double square brackets, one of these variables pop up. You type these in, you click on this variable, this menu pops up, and you just enter whatever you want in there. And then the other thing is these angled brackets. The angled brackets tells it, okay, I want a blank. So this is, in this case, there's only the one blank, but you can have blank 1, 2, 3, 4, 5, and so on. Okay, so in this case, you say, right, so B is blank, and then milliteslas, and then you click over here. This will just be an empty box. You click here, you type in what the value is, and you're good to go. So for this particular one, you tell it these variables, and it will just replace them with whatever numbers that individual student was given, and then just compare. And well, the next page I'll show, there's like a tolerance built in. So you can just say they need to get it right within 1%. And so if I'm giving them 2 decimal places and it's within 1%, hopefully they get the right answer. In terms of images, it doesn't take PDFs, but it will take like GIFs and JPEGs and stuff. And you just literally just drag them in here and the image pops up. So it's really easy to just create these things. So this is not actually the student view. This is the preview. The students don't get the edit button because they can't edit your questions. They can't re-randomize your numbers. But this is roughly what they get. So they just get the question. There's a box. They click on the box. They click down here. They either type it in if they got a keyboard, or they click on the keyboard button down here if they're using a phone, and then they can just type in the answer. And one of the really nice things when we're getting to the variables is if you just type in PHI, it auto replaces it with the symbol phi. So it's really nice. You don't have to put the slashes for LaTeX. You just type in THETA and it auto replaces with theta. So it's a really nice user friendly interface in my opinion. Okay, so here's an example that I think this is one of the examples I actually used in my electricity and magnetism course. So you can see, I say, here's some function. We need to figure out what is the flux of the curl of this function through this triangle. And part of this was either the next thing or the previous thing we did is we did the line integral around the triangle. We just wanted to show that they're the same sort of thing. And so this, so these are the boxes that they have to click on. So they have to click on each one of these and type in their answer. So for DZ, we're going from 0 to 2. And I'm not going to tell you the rest of them because this is going to be our first example for people who want to try it. So this is just, actually, let me get it started here. So yeah, if you've got your phone, you want to try it, you can just get your QR code. If you go to that QR code, it should just bring you straight there. And the question is just now started. So the idea is anywhere in LaTeX at all during even the middle of the equation, I can drop a blank, even in like the limits of this integral. So you can put blanks anywhere you want and have them fill them in. Okay, so I'll just give people, 3 minutes or so to play around if you want to take a look at it. Oh yes, sorry, I forgot to say, it normally asks you to log in, but I set this up so you don't have to. So just say, skip and start learning. You don't have to log in as a student. It won't record who you are. It won't ask for your email address. You can just keep going, just jump straight in. Ordinarily for your class, obviously you wouldn't do that. You would want to keep track of who they are. Yeah.
Reminds me a lot how Desmos works.
Mm-hmm.
The same, or is it very simple? Like the way that people like typing phi to.
I would assume that Jonathan used the best practices that were available. Yeah. So it wouldn't surprise me if Desmos was an inspiration for that. Okay. And on my phone, it's saying still nobody has actually hit the submit button, I guess. And if you have any questions and you're not busy doing this, feel free to get to ask. Just. Oh, we've got 4 people with answers in. Okay, so I can see. People are getting that limit right. And mostly getting that limit right. Oh, not everybody's getting the lower limit of the second integral right. Oh, the upper limit of the second integral is, so this one here is giving people difficulty, which is expected of the first time you're doing it. Like in a class, I would expect actually that one to be the trickiest. Ooh, and we are all over the place on that integrand. Yeah. It won't let you. It won't let you? I don't know why it's saying it won't let you. Some people are. So at least 3 people have the answer in there. That's a variable that a formula that works for me, that I think is right. Okay. Anyways, I mean, this isn't actually a class, so I guess that's probably long enough. So now I can just show you. So the next thing you can do is you just say, okay, reveal the answer to everyone. You can either show them what they've been putting in, or you can just actually reveal the correct answer. So I'll just break that a little early. Ordinarily in a class, I would definitely give people like at least 5 minutes to do this, just because they have to write it down and then they have to get it in and they have to hit the submit button. Okay, so if you did enter something, it should have pushed onto your screen what the correct answers were and presumably whether you got it right. So what do you got? We got 70% recognize that we're integrating from 0. And how many people? And about 60% got that we're integrating from 0 to 2 for dz and so on. So I've got all the feedback here I need, which means when I'm doing this during class, if everybody's getting this part of the integral right, but this wrong, well, I know what to spend time on. We can just focus on solving this question and saying, okay, well, everybody got this, so I'll just, and I would still answer all of the questions because there's always some people that didn't, and you just want to have a, help everybody. But if everybody's getting this wrong and most people are getting this right, I'm going to spend more of my time in the remaining part of the class figuring out why this should be going from 0 to 2 minus z instead of from 0 to 2. Okay, so this is why it's useful as an in-class sort of assessment. Okay, the other thing you can do, so this is an example of a question that I built more around like as a post-class question. So this is a ring of current, and we've got some point up here that's on axis. It's right over the center of your loop. And the question is, so what is the magnetic field here? And this kind of question, I sort of tripped over by accident because once when I was typing an equation, I put angle 1 twice and then realized that I'd reused the number. And it turns out MathMatize is perfectly fine with that. If you do that, when you type in your answer to one of the boxes, it just auto-completes it for you in the other one. And as soon as you do that, then this sort of question becomes quite easy. Actually, I'll just start it up for anybody who wants to take a look at it. No, there we go. So I'll just start up if you want to look at it. But basically what I did is I went through step by step. So this is a scaffolded problem where step 1 is, what is this R vector? It points from here to here, but what does it actually look like? So we've got, it's like blank S hat plus blank phi hat plus blank Z hat, and they have to put all 3 in there. And then the next step is, okay, I told them what the DL prime vector is. What is the cross product of DL prime and R vector, right? And that gives you the integrand, well, and then you have to divide by R cubed to get the Biot-Savart law correct. And so I put in the Biot-Savart law in there for them, but all the blanks are reused from the earlier questions. And so they have to set up this R vector, which isn't trivial the first few times they do it in electricity and magnetism course. So they are making mistakes here. Then they have to do the cross product, and in non-Cartesian coordinates, they don't always get the cross products right. But when they've got the feedback, then I can see right away most of the class is getting this wrong, so I have to worry about the cross product more. But everybody was doing the R vector right, so I don't have to spend too much time on that. And again, this is the sort of thing that I was building towards. And it was just fortuitous that I learned that if you accidentally put the same blank in, it just auto-populates it for you and it fills them both in. Okay. So this is the sort of thing that I've been doing more of lately, and what I would push more in the future. It's it's basically scaffolded problems, scaffolded homework questions. In principle, I think you could create fairly sophisticated quizzes and almost test sort of assessments using this sort of thing. but I personally hesitate to do so because you're only marking the results and you're giving them like a lot of scaffolding for the test. It's perfectly fine on a homework assessment as far as I'm concerned, but on a test, you're doing all the logical flow for them, right? So yes, you could build a test, and if the pandemic came back and we had to switch back to doing online tests, I think this is the approach I would probably try to use in the future, especially for the second, third year, fourth year courses. But I would still like the traditional tests and exams. I still like the start with these axioms, show the logical narrative of how you get to this answer. I think that's just an important skill. And so I would keep that in there. Okay. Okay, so as usual, I talk fast. So I will give you guys roughly 10 minutes of your life back earlier. Thank you for showing up. But basically, the summary is, I think MathMatize is really cool. The mathematical equivalence is a really, really useful tool that I haven't seen in other similar education tools. I like it. In fact, this is a weak word. I'm really, really a fan. As I said, I kind of drunk the Kool-Aid on MathMatize. So again, please, Peter, keep approving this expense in the future. It's really good. It's also easy to download the grades. So as long as you set it up so that you take your roster from Quirkus, you download your roster from Quirkus, including the email addresses, which there is a way to do. Ask April if you don't know how to do it. You do that, you upload it to the MathMatize system, and you include their uTor IDs. And then when you download the grades, it's easy to do those matches, because if you let them self-sign up, they'll use different email addresses. They won't always use the same names that are on Quirkus. But you've done this, you've given them the uTor ID, and then everything just locks in super easy. And it's really, really easy to download the grades and put them back into Quirkus. Okay? There is a significant learning curve. For example, LaTeX has epsilon and var epsilon. Both of those exist in MathMatize, but obviously they're different symbols, right? So if you're doing an electricity and magnetism course, like I am, and you want them to put in the 1/4 pi epsilon naughts, which I asked them to and then sort of stopped doing because of this difficulty, you just have to make sure you say, hey, both of these answers are acceptable. And you just have to type in answer 1 with epsilon, add another answer. It's a little extra work. I find it easier for me to just factor out the epsilon naughts, and that's what I actually do. But there's little things like that. I've only found one bug, and that bug was some weird, obscure thing where when you're typing in the epsilons on a phone, it didn't work for some phones, but did for others, but on the computer it was perfectly fine. Otherwise, there are no bugs. Right? This system has been very, very reliable, and I'm really, really happy with it and its stability. Okay, so I'm done. Like I said, 10 minutes early, I'll give you 10 minutes of your life back.
Yeah, thanks for advertising MathMatize, giving us some good examples about what to do for MathMatize. I'm thinking about what I'm doing next semester, and this is now something I'll be thinking about. So are there any questions to Brian? Or online?
Online? Okay.
So, question from David Bailey. Is there any drop-off in students doing quizzes if they reach the 2/3 threshold for getting full marks from the formative pool? Or do they truly appreciate that the quizzes are helping them learning and continuing doing so?
I don't
Continue doing them.
So yeah, so in terms of drop off at the 2/3 mark, I don't see a big drop off that's like precipitous. I see a slow decline through the semester, but I kind of think that's sort of standard for all the courses, to be honest. One of the things is, while students certainly have the information to calculate their grade, they don't. And so if I don't calculate their grade halfway through this semester, they don't actually know what their grade is. And for the most part, they just keep saying, well, I'll just keep going just in case, just in case, just in case. So I haven't noticed that, no.
Thank you.
Thanks. For in-class use, you mentioned, you would use it in class and maybe give them 5 minutes to work on it. And so if you do that 3 times, that's 15 minutes. You're cutting into your lecture time. Where's the balance? How do you determine, the amount of time to use for in-class quizzes and not, sort of hamper the amount of material you're trying to get across?
Yes, that's a very good question, is the time use. And that's the standard question of everything about active learning, right? Active learning is always about the conscious decision to sacrifice the breadth of material you're going to cover individual material deeply. To be honest, one of the biggest negative feedbacks I've had is how little time I give them. And so now I'm giving them like between 10 and 12 minutes per question. And so honestly, I can do 1 per class pretty reliably. It's not frequent at least in my second year E&M course. I rarely get to 2 questions in any given class. So 1 is all I can sort of do. I sort of aim for the middle. So like I talk for 10 minutes, we do an example. I talk for 10 minutes, we do a MathMatize question, talk for 10 minutes, and then the class is already over. So for me, I find it actually difficult in 1 hour to do more than 1 of these questions. In a first year course where they're not usually long derivations, they're like shorter, almost just plug and chug, does this equation work? Then I can get 2 or 3, but those are 2 or 3 like 5-minute questions, not these open-ended questions. And the multiple choice tends to be faster.
Can you imagine using this in a 3rd or 4th year course?
Absolutely, yeah. So I'm not as sure about, for example, 3rd year quantum mechanics course, simply because I'm not sure the bracket notation will actually translate properly through their system. I'm not sure if it recognizes those symbols as being attached to this variable. But other than that, yeah, as long as you don't have specific weird symbols to use, I actually think like it just does equations. As long as you've got anything where the answer is an equation, it works in MathMatize quite easily.
Thanks.
Red shirt. Oh.
There. Sorry.
As a survivor of the so-called Physics 180 class many moons ago, one of the, I guess, like trends that start percolating as you get further into the semester is how useful is the work I'm doing versus like some kind of end goal, typically the final exam you're taking. And it's common that these like shorter, smaller homework questions tend to be very plug and chug and repetitive. One thing I was maybe hoping to see in the MathMatize is a feature where perhaps you could redo some questions that you had trouble with and like re-randomize the numbers you were getting. So kind of the advantage of not using a textbook and using a digital platform is that that you can't regenerate the textbook, but you have this platform. Surely you should be able to regenerate some numbers, or maybe sample different questions to maybe extract more thoughtful value rather than just plug and chug and kind of doing this checking along the way.
Yeah, I agree. And at least for my in-class questions for the electricity and magnetism, whenever I close them, I 90% of the time remember to close them and make them available for review. And in principle, I should ask some of the students to make sure this is what's happening, but in principle for review, they can go in after the fact and just redo that question over and over and over with infinite loops. It doesn't change their grade, but they can just keep going over and over. And because I'm mostly doing variables, not numbers with random distributions, I assume but don't know that if I did that, each time they do it, it would give them a different set of random numbers. So MathMatize has some of that, at least for the polls. I don't know if it does that for the homework questions, the after class quizzes, but I give them like at least usually 3 attempts to do it anyways, and about 95% of the class is getting perfect on them at that point.
Fair enough. It's a good point you mentioned for second year EM, where a lot of the learning is late in geometry. You don't get the geometry at the first time. So having that ability to review and eventually it clicks is...
Yes. Yeah. The vector, I mean, I spent 4 of my 12 weeks just reviewing vector calculus because it's not trivial.
So I used it. One thing I hated, 2 things I love that you didn't mention. The thing I hated is it does not understand exponents, like two e to the minus 11, like it because it's mathematicians, I guess. So if you have a very small number, they have to count the zeros. So
right.
whenever you have an H bar or a G, you have to be clever with how you cast your units. It's a bit of work. Two things I loved. If you're short on time for preparation, there's an online bank of questions. There's a search engine, so you can reuse other profs' questions. And the second thing I loved, randomizations of inputs, like a distance in meters, like you can randomize that number. Oh, you
Yeah, you can randomize all these numbers, right?
you mentioned it.
Yeah.
Oh.
Yeah, the randomizing of numbers is a fantastic tool, especially for like a first year course.
I never listened in class. Okay.
Thanks. I have heard, by the way, what you can. I have been told that they've recently implemented units properly, and so if you decided to switch to electron volts so that the numbers aren't 10 to the minus blah 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 blah. Now, in 131 or 132, that might present its own problems, but in 151, I hope switching units to electron volts might be a reasonable thing to do. But hopefully, that's supposed to be working. Yep.
Now made you run all the way over here. Thanks a lot, Brian. So you talked about three kind of attributes of these formative assessments. So it was suitability, which I think you got that covered, and the last one was feedback, and this really gives you that. But in terms of utility, like what's the, I guess the through line from this kind of testing to the actual exam? How does your use of MathMatize actually influence the kind of longer questions that you're assigning for homework and everything? Or is there, like, do students see the utility there? Because they, in the end, they do need to do these summative assessments, right? And you still need to worry about that. You know, you said, I've got that covered, but at the same time. So I'm wondering if and I would say that might speak to the utility. I guess I was trying to understand what you meant by utility and how this feeds into it, because I don't know if that was as clear to me as the other attributes.
Yeah, so I guess in my mind, the in-class questions have low utility towards the final exam, but they're just meant to be, you're sitting in this class, we just talked about a thing, did you get that thing? And so that utility is just for students who care to show up to class, which is, 50, 60% maybe. They're showing up to class, they're listening, and they're getting that feedback right away of, hey, I got it, or no, I don't got this. So I think there's an obvious utility to my use there, because it's clearly saying, did you fall asleep during that class or not? My post-class questions, they tend to be, roughly speaking, on the difficulty level of the easier side of exam questions. And so you've had one day to think about it. If you had to sit down on the exam, could you at least get the easy question on that? And then my homework questions are typically more geared up. These are on the hard side of exams. And I make that kind of explicit, I think, to my students. I'm not sure I could ask them if that succeeded or not, because I see something here. But I think I try to make it clear that, and this is something I think everyone needs to do as the instructor, figure out what you're doing, do your best to make it have utility, and then tell the students what the utility is. Like one of the things I think probably works is at the beginning of the year, I tell them that those formative assessments are literally me just bribing them to please do the stuff you have to do in order to do well in the exam. And it's literally just a bribe for that. And I want to say that this is working, but maybe I should ask one of them if that's their experience as well as mine. Is it working? 1, 2, 2.5 thumbs up out of 3. So. Of course, what were they going to say in front of me, right? Yes, these are my followers. Oh, is there another online question?
I think it's 2 questions, but they are really similar, so I might just ask them together. The first question is, how can MathMatize be combined with AI to further enhance learning outcomes? The second question is, you say MathMatize doesn't yet use AI. How do you see AI affecting such formative assessment in future?
Yes, so I haven't learned enough yet about AI, although I'm coming up on a half sabbatical, and AI is what I'm going to spend my time doing. So I'll hopefully have a much better answer to that question in about 8 months or so. For the first piece, I have no good sense of how much AI is good at generating new questions for you. I certainly don't use AI to generate any of my homework questions, any of my MathMatize questions, any of that. I just don't trust them to be effective. So I don't actually have a comment on that yet. But for sort of the opposite view of how is the use of AI impacting our formative assessments, I think the impact is huge. And I think largely what it does is as soon as the students don't see the utility in doing your work, I think they can really easily jump to using AI to answer for them. And basically it's what we consider cheating. I have some hesitations to use the word cheating in that sense because I have some hesitations towards saying we should be teaching students things that are easy to replace by AI, because that utility for the students isn't high. Right? If our students are no better than AI, they're not going to be employable. So I have some other issues. I wouldn't necessarily call it cheating, but realistically, it basically is cheating. And I think the best way to combat the use of AI in ways you don't want them to is to reduce the workload, to make sure that their utility is very, very clear to them. And at some level, just trust that if you come out and tell them, this is why the homework exists, this is how it will help you learn, this is how it'll help you pass the exam, then by and large, most of the students will do that. Certainly not all of them, but I mean, 20 years ago, were all the students doing the homework properly, or were some of them copying their friends? Like, there are stories of people with sticks with gum at the end going into drop boxes to pull up a homework assignment. Like, that's always existed. We can't get rid of it completely. Okay.
That's their question. Any other questions? So I guess I have a question related to marking. So you said that you had completeness. Mark, do you say you have to get all the boxes right to get the full mark? Or is it like you only have to get a certain number of boxes right? Or how do you deal with the marking side of things?
The percentage of boxes they get correct is their percentage score on that assessment.
Right.
So if they get 6 out of 8 boxes right today, they get 75% for today. And then I weight each day separately. So if the one class I've got 8 blanks and the next class I have 1, they're still both equally weighted. I try to avoid the ones where there's just the 1 box so that there's more partial credit. But yeah, it's just whatever that score is. And by the end of the semester, as long as they get enough partial scores that it adds up to 67%, they get everything.
Any other last questions? Seeing no other questions, thanks again for a great presentation.